In this video, I'll be explaining the various laws of indices. Okay. Now, before we jump directly to the laws, what is indices itself? Indices is the plural of index. It is the plural of index, and index simply means power or exponent. Okay. So for example, I can say this is 2 raised to power 4. I can say 2 to exponent 4. So this is the concept of, this is what we call an index. This is index. So let's look at the various laws of indices. For example, the laws of indices can be broken down into different numbers of laws. Okay, so but for this tutorial, I have decided to break it down into 7 laws. Okay, now the first law says if we have a base, like this, we have a number, or we have a variable raised to power a number or another variable, multiplying that same base raised to power a variable or another number, it can be simplified to a and to x raised to power a plus b. If what we have between these two variables of the same base is divide, then it is going to be subtraction. Okay, that's law number 2. Law number 3, x raised to power 0 is 1, provided that x is not 0. For example, if I say this is, for example, if I say x, or if I say 20 raised to power 0 is 1. So basically anything raised to power 0, if that number is not 0 itself, okay, the result is 1. Okay, now this number 4 now, x raised to power minus a is simplified to give 1 over x raised to power a. Okay, that is, it is inverted. Whenever it is inverted, it loses this raised to power, this negative power. Okay, now whenever you have an expression inside the bracket raised to power n, all the expression inside that bracket carries that power n. For example, if I have x raised to power a, all raised to power n gives us x raised to power a n. This can be further expanded to, let's say we have something like, let's say we have 20x raised to power 2, all raised to power 3. Okay, this entire expression owns this power 3. So this 20, so we are going to have 20 raised to power 3, and we have x raised to power 2 times 3, which is 6. Okay, so take note of this. Now, also when we have a fraction raised to power a particular number or a particular variable, they both share that power, or both the numerator and denominator share that power. So it's the same as x raised to power a and y raised to power a. Okay, and the final one is whenever we have a variable or a number raised to power a fraction, okay, the numerator becomes a power and the denominator becomes the roots. So for example, if what we have here is 2, if this b here is 2, then it becomes square root. If it is 3, it becomes cube root. Okay, and so on. For example, let's look at a typical example, e.g., let's say we have 8 raised to power 2 over 3. Okay, this is simply the same thing as 8 raised to power cube root of 3 all squared. Okay, which gives us what? 2. Cube root of 8, cube root of 8 is 2, so 2 squared, which gives us what? 4. So take note of this. Now, to further reinforce our knowledge, let's quickly do this example. Okay, these are basic example level. Now, in subsequent class, we'll look at much more deeper example. Now, the first one now, we have number 1, where we have 2a multiplied by 3a squared. Now, observe, we can, this is the constants multiply themselves. I can break this one down to 2 times a times 3 times a squared. Then I multiply 2 times 3 to get 6. Then I multiply a, this is the same as a raised to power 1 here. So according to law of indices, this is the same as a raised to power 1 plus 2. Okay, which gives us what? 6a raised to power 3. That's the first one. The second one now. Now observe, the second one, we have 2a all raised to power 2 multiplying 3a. What does this give us? We can expand this bracket such that we have 2 raised to power 2, then a raised to power 2 times 3a. Now 2 raised to power 2 gives us 4. So we can have 4 multiplied by 3, which will give us 12. Okay, then a squared multiplied by a, this is the same as a raised to power 1, which will give us what? A raised to power 2 plus 1, and we have 12 a raised to power 3. So that is simplified. Then the third one now, 2 raised to power minus 1 multiplied by 2 raised to power 3. So they are both, the base are the same. This one is very easy. So we just say 2 raised to power minus 1 plus 3. And what is minus 1 plus 3? That is 2 raised to power 2, which can be written as 4. Okay, very easy. Now number 4 now. Number 4, also we have 1 over 9 raised to power minus 1. And now don't forget, whenever you have a negative power, the easiest thing is just to flip whatever expression you have that is carrying that minus 1. So in this case, it is 1 over 9 raised to power minus 1. So my answer is just going to be, just flip this. The answer is the same thing as 9 over 1, then raised to power 1, whatever we have here. Okay, so our answer is basically 9. Okay, number 5. Now, this is division. Okay, quite different from the previous examples. Now let's look at this. Very easy. The same way, you can split this 10 a raised power minus 2 divided by 2 raised power a raised power 6. 2 a raised power 6. You can split this to 10 dividing our 2. Okay, this 10 dividing 2. Then what? Then a raised power minus 2 dividing a raised power 6. Okay, 10 divided 2 gives us 5. Okay, then a raised power minus 2 dividing a raised power 6 give us, no, according to the laws of indices, this will be a raised power minus 2 minus 6. Okay, so, and on further simplification, what will this give us? This will simply give us 5 a raised power minus 8. Okay, you can decide to apply the law number 4 that we have here, such that this a raised to power minus 8 will now become 5 multiplying 1 over a raised to power 8, okay, which is the same thing as 5 over a raised to power 8. So with this, we have been able to completely solve these examples. Yeah, so there are more further examples we are going to solve in the next video. Thank you. Hi. So in our journey to understanding the laws of indices and its application, that is how to use the laws of indices properly. So let's look at some further examples. Now we have example 1 here. We have the cube root of 8a raised to the power minus 6. How do we solve this? Now remember, out of the laws we discussed in the previous video, this expression can be rewritten as 8a raised to the power minus 6 raised to the power 1 over 3. Okay, if you remember, this is the cube root. 1/3 is the same thing as the cube root of an expression. So now this, we can expand this bracket such that we can have 8 raised to the power 1 over 3 times our a raised to the power minus 6 also multiplied by 1 over 3. Okay, now on further expansion, this, okay, you should be able to see that this is actually the cube root of 8, which is 2. But in case you cannot see that, it is easy to write 8 as 2 raised to the power 3 or raised to the power 1 over 3 now. Then this is the same thing as a raised to the power 3 cancels 6, so that we can have minus 2. Okay, that is 3 here 1, 3 here 2, so we have minus 2 here. While this is also 3 here 1, 3 here 1, so we have 2 multiplied by a raised to the power minus 2, or simply 2 over, we can also change this, it will become 2 over a squared. That is, you flip it to remove the negative sign. Now, number 2 now, question number 2. For question number 2, we have 16 over 9 raised to the power minus 3 over 2. Whenever you see this and there's a negative power, just simply flip the expression, the expression in the bracket to remove the negative sign. So this just gives us 9 over 16 raised to the power 3 over 2. Okay, so now we can now expand. I can rewrite this 9. Actually, observe that we can write 9 as 3 raised to the power 2, and we can write 16 as, you can write it as 4 raised to the power 2, all raised to the power 3 over 2. Let's take it gradual. So now if we expand this with the power, so we can have 3 raised to the power 2 times 3 over 2 all over 4 raised to the power 2 times also 3 over 2. Now this gives us what? 2 times this gives us 3 raised to the power 3, okay, because this 2 cancels. Same thing, this 2 also cancels, so we have 4 raised to the power 3 also. Okay, so you can decide to get the final answer of this, okay, which I'm going to write up here, which is going to give us 3 raised to the power 3 is 27, while 4 raised to the power 3 is 64. Okay, so that is as easy as that. Now let's move on to question number 3. Now in question number 3, we also have the fourth root of 16a raised to the power minus 12. Okay, we can apply the same thing we did in number 1. Same thing can be written as 16a raised to the power minus 12 all raised to the power 1 over 4. It's easier this way, okay, so that you can now visualize that, okay, 16 can be written as 2 raised to the power 4, okay, and this is a raised to the power minus 12 all raised to the power 1 over 4. We're trying to take it gradual. Now we can expand now using the power on each item multiplying themselves in the bracket. So this becomes 2 raised to the power 4 multiplied by 1 over 4. Okay, then a raised to the power minus 12 multiplied by 1 over 4. Okay, these are power. So this 4 can eliminate this 4 such that we can have 2 multiplied by, then the 4 here, this 4 here 1, 4 here 3. So we can have a raised to the power minus 3. Okay, so the same thing, you can remove this negative by letting this a comes down. So we have 2 over a raised to the power 3. That is also done. Now let's move on to question number 4 now. Question number 4, okay, is looking large, but it's actually very easy. So now, in question number 4, you have 75 over 5, 75 multiplied by a raised to the power 2, b raised to the power minus 2, then 5, a raised to the power 3, b raised to the power minus 3. Okay, observe that 5 can simply divide, and we have 5 into 7 gives us 1, meaning 2 gives us 15. So the same thing, that means we have 15. Now observe that this is a raised to the power 2 divided by a raised to the power 3, which is a raised to the power 2 minus 3. Then this is b raised to the power minus 2 divided by b raised to the power minus 3. That gives us b raised to the power minus 2 minus of minus 3. Okay, you have to, because it is division, it has to be minus of minus 2 and minus 3. So what would this give us? This gives us 15. A raised to the power 2 minus 3 is minus 1. Okay, then we have b raised to the power minus 2. This gives us minus 2. Minus times minus gives us plus 3. Okay, so on further simplification, we see that this is 5 a raised to the power minus 1 and b raised to the power 1. Okay, you can decide to rewrite this also as what? As 15. This a can go down as over a, then b stays. So we have 15b over a. As easy as that. Now we have one more to solve. That's question number 5. And question number 5 is just 36x raised to the power minus 2 raised to the power minus half. Okay, now you can also expand this, okay, or you can decide to apply flipping before, but let's first of all apply it before flipping. So we can, this is the same thing as this is 6 raised to the power 2, right? And this is x raised to the power minus 2, or raised to the power minus 1 over 2. Now we can open the bracket with the power such that we can have 6 raised to the power 2 multiplied by minus 1 over 2. Okay, then x raised to the power minus 2 multiplied by minus 1 over 2. Okay, now observe that this 2 also cancels this 2 such that we have 6 raised to the power minus 1, and this 2 also cancels this 2 such that we have x raised to the power minus 1 times minus 1. Alright, so this gives us 1 over 6. Okay, and this minus 1 times minus 1 is just 1, so which gives us ordinary x. So the answer can be written as 1 over 6 of x, or can basically be written as x over 6. So with this, we have been able to solve all the various examples we intend to solve. So see you in the next video. We are going to solve more examples before we move on to integral equation. Thank you. Okay, so let's continue with solving more examples on laws of indices. Now, if you have been following this class, you can quickly pause this video and attempt to solve these questions, then come back to see my solution. Now, let's start with question number 1. Question number 1, we have 16 raised to the power minus half multiplied by 4 raised to the power minus half multiplied by 27 raised to the power 1 over 3. Now, there are many approaches to start this problem, but I'm going to be using this approach. 16 can be written as 2 raised to the power 4. Okay, then all raised to the power minus 1 over 2. Then 4 can be written as 2 raised to the power 2. Then raised to the power minus 1 over 2. Then 27 can be written as 3 raised to the power 3. Then multiplied by 1 over raised to the power 1 over multiplied by 1 over 3. So now you see that this can simplify to give us 2 here 1, 2 here 2. Okay, 2 goes here such that we have 2 raised to the power minus 2 eventually, and these 2 eliminate such that we have 2 raised to the power minus 1. Then multiply by this 3 also eliminates here, so that we have 3 raised to the power 1. Now you can just apply the law of indices here such that you have 2 raised to the power minus 2 minus 1, then everything multiplied by 3. Then this gives you 2 raised to the power minus 3 multiplied by 3. 2 raised to the power minus 3 is the same thing as 1 over 2 raised to the power 3 multiplied by 3. Okay, 2 raised power, this is which is 1. 2 raised power 3 is that's 8 multiplied by 3. So our answer is going to be 3 over 8. So there are many other approach you can use. Okay, but this, I feel this is easier to understand. Now, number 2. Let's move on to number 2. Now, number 2, also, if you have watched our previous example, I've told you that whenever you have a negative uh, power, you can quickly flip whatever is in the bracket such that this becomes 16 over 81, and our negative sign, our negative power there is gone. It now becomes ordinary 1 over 4. Then multiply by 2 raised to power 1, which is the same thing as 1 over 2. Okay? Now, 16 can be written as 2 raised to power 4, obviously, and 81 can be written as 3 raised to power 4, or raised to power 1 over 4. Okay, times 1 over 2. So if you use this power on both the numerator and the denominator, you have 2 raised to power 4 times 1 over 4, and 3 raised to power 4 times 1 over 4, which will simply give you 1 in each case. So multiply by our 1 over 2. So we have 2 over 3, okay, multiplied by 1 over 2. So which will give us 2 here, 1, 2 here, 1. So which will give us 1 over 3 as our final answer. So that's easy to understand too. And we move on to the third example. Now, this is our example 3. Okay, this one also, you can quickly see that you can rewrite this as 125 squared, all raised to power minus 1 over 3. Then this square root can be written as raised to power half. Okay, now this one, what we have inside there can be written as 5 raised to power 3. So you agree with me that we have 5 raised to power 3 times the initial power that was there, that's 2. Then everything now raised to power, this half multiplied by 1 over 3 will give us raised to power 1 over 6. Okay, 1 multiplied by 1 gives 1. 3 multiplied by 2 gives us 6. So now, what we have here is now going to be 5 raised to power 6, all raised to power minus 1 over 6. So you can see that 6 also eliminates here. So we have 5 raised to power minus 1, which will give us 1 over 5. So it's as easy as that. So these are some examples. At least we have solved 13 examples in this tutorial. So if you have any further questions that you think you are finding difficult to solve, you can drop them in the comment section, and I will gladly provide solution for them. So check out in the next video. In the next video, we are going to start discussing integral equations, which are equations that leads the equations that involves indices. Okay, so see you in the next video.